As climate changes, one of the obvious impacts of that change is changes in the water cycle. We know that water is sensitive to changes in precipitation. That's fairly obvious. If we get less precipitation, there's less water on the land surface. But we don't know very much about the mechanisms that control that. So fundamentally, the water cycle starts with precipitation. But once the water's on the ground, where we use it for water resources, for drinking water, for irrigation and agriculture, it falls in the domain of how the water interacts with the land surface. The changing climate, coupled with the fact that we don't know a whole lot about the mechanisms between climate, weather, and land surface hydrology, mean that we have a difficult time trying to predict exactly what's going to happen with surface water resources nationally and globally. 60% of the northern hemisphere gets snow cover in winter, at some point during the winter. If you look at the Earth's total land mass, about 35% of the Earth's land mass gets snow cover at some time during the winter. So there's a lot of snow. Snow is a big part of the water cycle. It's a major storage term, meaning that precipitation falls and it runs off into the streams, and the streams run into the ocean. But there's an intermediate step in there, which is the water's often stored along the way. It's stored in lakes, it's stored in the soil, and it's stored in snowpacks. Because so much of the Earth experiences snowfall and snow accumulation and the formation of snowpacks, it makes it a pretty significant storage term in the water cycle. You want to try to understand how climate change affects water availability and water resources, floods, flood frequency, that sort of thing. We need to know essentially how big is the reservoir, how much storage is going on, how much of the precipitation doesn't immediately run off into the rivers and oceans. The CLPX experiment was initiated by interest in a new satellite sensor to specifically measure snow. The impetus for trying to sort out what do you need in a satellite sensor to measure snow better than we currently can led us to the conclusion that we really don't have enough data to answer that question, and we needed to have a field experiment that would provide the necessary remote sensing data as well as the ground data, the ground truth data, to support decisions involving what frequencies in a sensor or what type of sensor would be used. The other side of CLPX is initiated from the fundamental science, the understanding of snow processes, cold land processes, that's needed to get into the models that forecast and predict weather and climate and water resources in an effort to improve the models and improve predictions. So we have sort of a two-pronged impetus for this experiment. One, to improve the remote sensing, the measurements themselves, and the other is to improve the models and the ability to predict cold land processes.
The number one concern we have is safety. Everything else comes second. We can't put people in the field without that as our number one priority. This is different than a lot of field experiments. Some field experiments you can carry out the entire thing in a pair of shorts and flip-flops. Some field experiments people do, and they never get more than an arm's throw from a vehicle or a warm place. We're working out here at high elevations in high winds, high snow, remote locations, miles and miles from the nearest warm vehicle and the hotel. And there's all kinds of natural hazards that we have to deal with, and just the environment, even when we don't have things come up that are unexpected, is a relatively harsh environment. The second priority, of course, is data and data quality. If we put this much energy and time and effort into an experiment like this, there's no point in doing it if we aren't getting data that means something and that are valuable to the project and to the future of this whole remote sensing type of endeavor. So it doesn't matter if you're safe out here and you have a good time and you collect a bunch of garbage. It's not going to help anybody. So we look at safety first, and then data quality second. The third priority is data volume. getting enough data to do it. We're in a mode where we'd rather have a little bit of good data than a lot of marginal data. So, again, back to this sort of prioritization of different facets of the project. We work on safety first, then getting good measurements, and if things are going well, we keep taking the measurements until we get a sufficient volume of measurements to do the things we want to do.
It's not necessarily straightforward that just because climate gets warmer or what have you, that there's less water or less snowpack. Often we see more snowpack form, large snowstorms like ones that Colorado had recently, even though supposedly we're in a warmer climate. What we're really in is a more variable climate, and in that increased variation, the effects on water supply for all the different uses become more and more unknown. So it's more important than it's ever been to understand what the mechanisms are between climate, weather, and water, and try to improve the models we use and the measurements we make, all in order to improve the prediction of what the future water supplies will be.